Alright, in this video we're going to cover the DMA 70 review. If you can do all or the majority of these problems, you will do just fine on the DMA 70 module exam. Let's go ahead and start with the first problem. We want to find all numbers for which the rational expression is not defined. In class we talked about this quite a bit. The only thing you want to focus on, where this rational expression will be not defined, is when the bottom is equal to 0. So set your denominator, x squared minus 6x plus 8, set that equal to 0, and let's solve this. I don't even care about the top. Don't focus any attention on the top right now. We're just trying to find where this bottom part is going to be 0, so we set the denominator equal to 0. When you factor this, two numbers that multiply to give you 8, that's a positive 8, and add to give you negative 6. Those two factors are going to be x minus 4, x minus 2. Because negative 4 times negative 2 is 8, negative 4 plus negative 2 is negative 6. Set each factor equal to 0, so x minus 4 equals 0, x minus 2 equals 0, and solving these two equations very quick. We add 4 to both sides, so x equals 4, and adding 2 to both sides, we get x equals 2. These are both values, or these are the only two values that make this rational expression undefined. Quickly, just plug in 4 back in. Watch what happens when you plug 4 into the bottom. Again, don't even worry about the top. Plug in 4 into the bottom. 4 squared is 16. 16 minus 24, because 6 times 4 is 24. So 16 minus 24 is negative 8, plus 8 does give you 0 at the bottom. Plugging in 2, we're going to get 0 as well. 2 squared is 4 minus 12, because 6 times 2 is 12. 4 minus 12 is negative 8, plus 8 gives you 0 there as well. So those are the two numbers for x that make that rational expression undefined. Number 2, if the average cost per unit, C of x, to produce x units of plywood is given by C of x equals 900 over x plus 30, what is the unit cost for 20 units? So this rational expression here, this function gives you the average cost per unit. So when we plug 20 into this rational expression, or into this function, what we get is C of 20 is equal to 900 over 20 plus 30. All we're really doing is just plugging 20 into there. I plugged in 20 right there, but we're not going to do any multiplying here. That's function notation. That means the average cost of 20 units is going to be equal to 900 divided by 50, and if you do 900 divided by 50, you get 18. So since this is a real world problem, let's make sure we leave our answer in a complete sentence. The average cost per unit for producing 20 units of plywood is going to be $18. Now, thinking about what this actually means, that doesn't mean that we can make 20 pieces of plywood for $18. This means if we make 20 pieces of plywood, the cost for each piece of plywood is going to be $18. And that's what that unit cost means. You're trying to figure out how much it's going to cost you to produce one unit. If we produce 20 pieces of plywood, each piece is going to cost us $18 to make. On to number 3, 4, and 5. We need to simplify. I've mentioned this in class. You don't want to cancel out the x squared. You don't want to cancel out the x's. You don't want to take 15 divided by 12 and 60 over 48. You can't do any of that stuff. What you need to do, you need to turn this stuff up here at the top into a multiplication problem. You need to factor. We factor, then cancel. Don't forget that. So up top we have a GCF of 15x. If you pull 15x out of 15x squared, you're left with x. If you pull 15x out of negative 60x, you're left with minus 4. Remember, you can quickly eyeball this and double check. If you take 15x times x, you get 15x squared. 15x times negative 4 is negative 60x. Down here at the bottom, we can pull out a 12x. When we do that, 12x factored out of 12x squared is going to leave us with x. 12x factored out of negative 48x gives us minus 4. Now we can start to cancel because everything up top is getting multiplied together. Everything at the bottom is getting multiplied together. So the x's go away, the x minus 4's go away. Right now we're looking at just 15 over 12. Maybe you did notice right here that they would simplify. We can simplify this fraction by dividing the top and bottom by 3. Therefore our final answer is going to be 5 over 4. 5/4 is our simplified answer to that rational expression. And number 4 works very similar to this. We can do a GCF up top, pulling a 2 out. That leaves us with x plus 1. At the bottom, a little bit more work to do here. We do have a GCF of 2. Pulling a 2 out of all these, that leaves us with 5x squared plus 7x plus 2. And just make sure you can distribute back and get this same trinomial here. A little bit of scratch work. We need to factor this even further. So doing bottoms up, x squared plus 7x plus 10. Just remind yourself, bottoms up, maybe it's been a while. We're moving the 5 over to the 2 to get 10. Now this thing here is not the same thing as what we have here. However, this is going to help us factor much quicker. 5 times 2 and 5 times 2 gives us 10, and 5 plus 2 gives you 7. So those are our two factors for this thing. But remember, since we moved the 5 using bottoms up, we can bring the 5 back. And from there, when we simplify, since 2/5 will not simplify, we do a bottoms up on that. So we have 5x plus 2. And this 5 over 5, that will simplify to give us x plus 1. So from there, writing this out, leaving the top alone for right now, 2 times x plus 1 over, there's a 2 over here, don't forget that one over here. And then the way we factored this to get 5x plus 2 and x plus 1. So now cancel out whatever you have in common at the top and bottom. The 2's cancel and the x plus 1's cancel. Do not put a 0 up here. There's still an understood 1 up there, and this is over. What do we have left at the bottom? 5x plus 2. Now you may question, why did I not put parentheses around this? If you wanted to, it's fine, but since there's nothing else getting multiplied at the bottom, you don't really need those parentheses. Either way works though. That's our final simplified answer for number 4. Number 5, we can factor this very quickly. Factoring the top, negative 5 times 2 gives us negative 10, and negative 5 plus 2 gives us negative 3. So we have y minus 5 and y plus 2 as our factors up top. Our two factors at the bottom, 7 times 2 gives you 14. 7 plus 2 gives you 9. So therefore we have y plus 7 and y plus 2. Simplifying quickly by canceling out the y plus 2's, our final answer is y minus 5 over y plus 7. And again here, this is that same idea. Since nothing else is getting multiplied up top, if you didn't include your parentheses, it's fine. If you did want to write your parentheses, I'm okay with that as well. But since there's no other multiplying going on, you don't really need them. Something to be careful with here, do not cancel out those y's because those y's are not getting multiplied. That is all you can do with this problem. It is totally simplified. 6 and 7, multiply and if possible simplify. We're going to take the same approach we just did with those last 3 problems. Let's factor everything. For example, 2p minus 2, we can pull a 2 out of that. So we're left with p minus 1. The p at the bottom, I'm okay with that. Times, now you can break the 6 up if you want, but I'm just going to leave it as 6p squared. Down here at the bottom, however, we definitely can pull a 9 out of that, and we're left with p minus 1. And now we can cancel out whatever we want because everything is getting multiplied. 2 times this junk times 6 times p squared all over p times 9 times p minus 1. That multiplication symbol isn't really that special anymore. It's just one big old fraction. So let's cancel out whatever we can. The p minus 1's cancel out. This p squared and this p. Since we have more p's at the top, we can take away one of those p's. That leaves us with p to the first. We're subtracting exponents there. Remember that p that I just crossed out right there? That had an understood exponent of 1. So when we subtract, we get p to the first. Let's multiply what we have left, because maybe you're getting a little confused with all these crossings or these things I'm crossing out. So up top, 2 times 6p, that's 12p up top, over, what do we have left at the bottom? Just 9. Now maybe you did realize you could cancel out this 6 and this 9. If you didn't, it's okay. Let's do it right now. Let's divide 12 and 9 by 3. 12 divided by 3 gives us 4. Let's leave the p up top. 9 divided by 3 gives us 3. So our final answer there's nothing else to cross out. So we have 4p over 3. Same thing down here for this problem. Let's factor, then cancel. So factoring these very quickly. 4 times 5 gives you 20. 4 plus 5 gives you 9. So that first two factors are going to be k plus 4, k plus 5. So we're done with that trinomial. The bottom, 5 times 5 is 25. 5 plus 5 is 10. So let's do k plus 5, k plus 5. You may wonder, could you write it as k plus 5 squared? Absolutely, but I'm going to leave it like this for right now. Moving on to this one here, GCF, we can pull a k out. So we have k times k plus 5. And now finally this bottom one, negative 6 times 4 gives you negative 24. Negative 6 plus 4 gives you negative 2. So therefore we have k minus 6 and k plus 4. And now that multiplication symbol, that just means everything is getting multiplied. Everything at the bottom is getting multiplied. So you can think of it as one big fraction and start canceling out. Well, we got a k plus 5, k plus 5. They cancel out. There's a k plus 5 and another one up there. They cancel out. And then the k plus 4s cancel out as well. So a lot of things crossed out. The only things we have left are k over k minus 6. Now you cannot cross those k's out. Do not do that. The reason why you cannot do that, write that back out. The reason why you cannot cross these two k's out here is because this k down here at the bottom is not getting multiplied. It's actually k minus 6. So that's all we can do for that one. All right, numbers 8 and 9. Very similar approach to the multiplication problems we just did, as long as you remember to keep, change, and flip. When you divide by a fraction, you change this operation to multiplication and you flip that fraction. It's also called multiplying by the reciprocal. So I'm going to do that first. X squared minus 25 over x times, so we keep that. We change our division to multiplication, and then you flip this rational expression right here. So we have x minus 5 over 8x plus 40. Now some of you may have thought, well, can you go ahead and factor as you're doing this? Sure. Just didn't want to do too much at one time, but that would work just fine. So factoring this, x squared minus 25, that's a difference of squares. X plus 5, x minus 5. And that was this one here. The x, we can only just leave the x alone. The x minus 5, can't do anything with that. However, that denominator here, we can pull an 8 out of that. So factoring an 8 out, you're left with x plus 5. So now you're focusing your attention on this. This is not the answer, but this is where we want to start to cross things out. The x plus 5 will cancel out with that one. Now these x minus 5s do not cancel since they're at the top. You have to have something at the top and something at the bottom in order to cancel things out. I don't see anything else that cancels out, so what we can do is we can write this as x minus 5. Let's go ahead and write it as squared now, because x minus 5 times x minus 5 is x minus 5 squared over, cleaning the bottom up, 8 times x is 8x. That's all we can do for that problem. All right, moving on to number 9. Let's do two things at one time. Let's keep, change, flip. So we're going to keep this, change our division to multiplication, and flip. But let's go ahead and factor at the same time. So we're going to keep this fraction the same, but we're going to go ahead and factor. 6 times 5 gives you 30. 6 plus 5 gives you 11. So z plus 6, z plus 5 over 6 times 7 gives you 42. 6 plus 7 gives you 13. So z plus 6, z plus 7. Let's remember to change our division to multiplication. And now when we flip, this bottom piece right here is going to become our numerator when we flip the fraction. 7 times 3 gives you 21. 7 plus 3 gives you 10. So we have z plus 7, z plus 3. And then our denominator, because we are flipping, so this is going to become the denominator. When we factor this, pull a z out, and you're left with z plus 5. So look at that. We did 2 steps at one time. We keep change flip, but in the process of doing that, we went ahead and factored everything. Just trying to work more efficiently, as long as you don't get too confused in the process. So now let's cross out anything we can. Since all this stuff is getting multiplied at the top and all this stuff is getting multiplied at the bottom, we can start to cancel. The z plus 6's cancel out, the z plus 5's cancel out, the z plus 7's cancel out. Therefore, your final simplified answer is going to be z plus 3 at the top over z at the bottom. That's all we can do there. Do not cancel those z's out now because that z right here is not getting multiplied. So that is your final answer. Alright, 10 and 11. Now we're going to add. To add fractions, you have to have a common denominator. We got to do the same thing with rational expressions. So, the way I talked about it in class is make the bottom pieces match up. So to do that, since this fraction has a r all by itself, that is not that same r. This is actually r minus 3. You can't separate those numbers. So since there's a r all by itself, we want a r all by itself in this fraction. Notice since I put a r at the bottom, you have to put a r at the top. Now, this fraction here has a r minus 3 in it, therefore this first fraction needs to have a r minus 3 in it. So if you put one at the bottom, make sure you put one at the top. That might look a little sloppy, but hey, let's clean it up. Therefore, from here we can take 6 times r minus 3 plus 7r, and notice I'm writing all of this as one fraction. The reason why I'm writing it as one fraction is because these two denominators match up. So writing it, which way do you want to write it? Like this or like this? I like it written like this. R times r minus 3. And now let's simplify the numerator. We leave the bottom alone, simplifying the numerator. So let's distribute. That's going to be 6r minus 18. Don't forget your plus 7r though. And at the bottom we have r times r minus 3. And then from here, let's see, 6r plus 7r, we have 13r minus 18. And at the bottom, r times r minus 3. And there is nothing else that we can do with that. That is our simplified answer to that problem. Let's get common denominators in this one now. But before I do that, I'm going to go ahead and factor the bottom pieces. You might say, why didn't you factor these? Because there was nothing to factor. However, we can definitely factor these two denominators here. Negative 2 times negative 1 gives you negative 3. Oh, excuse me, negative 2 times negative 1 gives you positive 2. Negative 2 plus negative 1 gives you negative 3. So we have y minus 2, y minus 1. This one here, this denominator, that's a difference of squares, so we can rewrite that as y plus 1 and y minus 1. Now maybe I should have left a little bit more room in my first fraction because we're going to have to tack on some stuff. Alright, so comparing these two denominators, they have to match up. Since this has a y minus 2, there's not one over here, so you got to put one over here. But make sure if you put it at the bottom, you put it at the top. This has a y minus 1 in it. That one has a y minus 1. So we're good with those. We're good with the y minus 2's, but now we need to deal with this y plus 1. Since there's a y plus 1 in this fraction must have one as well. But make sure you put it at the top. So now our denominators match up. Therefore, our next step, we can go ahead and combine these numerators together 2 times y plus 1 plus, be careful there, 7 times y minus 2. And this is all over, we can leave all this bottom stuff alone. But remember, you only write that common denominator down one time. You don't want to write all this down. So we have y minus 2, y minus 1, y plus 1. Doesn't really matter what order you put those in. And now let's clean up the top. Cleaning up the top, we distribute 2y plus 2. And then we have positive 7 times y. Notice I did say positive. We got to be careful in a few minutes when we do some subtractions. But that gives us 7y and minus 14. And this is all over y minus 2, y minus 1, y plus 1. And now let's clean this up. So from here, combining like terms up top, 7y or 2y plus 7y, that gives you 9y. 2 minus 14, that gives you a negative 12. I tell you what, we're still going to write this down here, but I'm going to go ahead and do one more thing. That part right there will factor. When we did 2y plus 7y to get 9y and 2 minus 14 to give us negative 12, we can factor out a 3, and that gives us y minus 4. Not y minus 4, it gives us 3y minus 4. Got to be careful there. Factor out a 3, and you're left with 3y minus 4. Now it is important to remember to factor when you combine like terms up top, because sometimes one of these factors will cancel out with what you have at the bottom. So all I really did there was a little bit of scratch work. I just combined like terms, I factored, now we can write our final answer out. 3 times 3y minus 4, and the bottom, copy all that stuff down again. Y minus 2, y minus 1, y plus 1. Now from there, and this is going to drive me nuts, I really shouldn't put that equal sign there because all that stuff is not equal to that. I just did a little bit of scratch work with this top piece to simplify that down. Now again, it is important to remember to try and factor, because had this been like a, suppose we pulled a 3 out and we got a y minus 1 in here, we could have canceled those two out, but we didn't. That's our final answer there. Nothing else crosses out, so that is totally simplified. On to some subtraction problems. Same idea, but we have to be careful with these minuses. Got to be careful with those. So, I'll tell you what, I'm going to go ahead and rewrite this out. 1 over x plus 1, a little bit extra space, minus 1 over x minus 1. And now what do we need? New. Since this has an x plus 1 in it, therefore we got to have an x plus 1 over here. Notice I am putting those parentheses there because I want to remember, and you need to remember, that we are multiplying these things when we put new pieces at the top and the bottom. Alright, so we got the x plus 1s, we're good there. Now we need to match up the x minus 1s. Since there's an x minus 1 over here, we got to have one right here. But make sure you put it at the top as well. So from here, lucky us, we just have numerators of 1. So 1 times this junk right here is still going to be that junk. It's just going to be x minus 1. However, be careful here. That minus, you have to be careful with that. So we have minus 1 times x plus 1, and our denominator, will leave it alone. Alright, from here, let's simplify this down. We got x minus 1. However, we have to remember this negative that I highlighted at the beginning. Notice it got carried on, and right here we have to multiply everything times negative 1. So negative 1 times x is negative x. Negative 1 times 1 gives you negative 1. This is still over x minus 1, x plus 1. And now simplifying the top. X minus x, those x's cancel out up top, but these 1's do not. Minus 1 is minus 2 over x minus 1, x plus 1. And that is our final simplified answer. So let's be careful with this one. This one's going to require a little bit more work. Let's go ahead and factor. So we have 7x up top. Down here at the bottom, -2 times -3 gives you 6. -2 plus -3 gives you -5. So x minus 2 and x minus 3 are those two factors. Don't be careful with your minus. You have 28. -4 times -2 gives you +8. -4 plus -2 gives you -6. So x minus 4, x minus 2. And let's leave a little bit of extra room. So what's some new stuff we need to get a common denominator since we're subtracting these fractions? This has a x minus 2, this has a x minus 2, so we're good there. Now we got an x minus 3 over here, so we got to make sure we have an x minus 3 on this side, but make sure you put it at the top as well. So we're good with the x minus 3's. And since this denominator has an x minus 4, we must put an x minus 4 in this first fraction. Make sure you put it at the bottom and then put it at the top. Alright, so we're good there. Next step. What we have is, how about we go ahead and do this? Since we have a common denominator, let's go ahead and start combining these numerators. So let's save ourselves some work and a little bit of time. Let's go ahead and distribute here. We have 7x squared minus 28x. And notice that that negative is crucial. So instead of this being a positive 28, it's actually a negative 28 times that stuff. So when we multiply negative 28 times x, that is minus 28x. Negative 28 times a negative 3, 28 times 3, we get a positive 84. Be careful there. Negative times a negative, when we multiply it here, that negative 28 times that negative 3 does give you a positive 84. And this is all over x minus 2, x minus 3, x minus 4. I don't care about the order of those since they're all binomials. Alright, let's go on one of our little tangents again. Let's just focus on the top piece, and we'll come back down here in a minute and write all this stuff out. Combining like terms at the top, you have 7x squared, 28 and 28, that's going to be 56. Just watch your sign. That is minus 56x. And then we have plus 84. Now this will definitely factor down some. How far we'll find out. We do have a GCF. We can pull a 7 out. That gives us x squared minus 8x. And 7 times 12, that will give us 84. So how about plus 12? This will factor even further. Now, when we pulled that 7 out, we have a trinomial that we can factor using the product sum. Negative 2 times negative 6 gives you positive 12, and negative 6 plus a negative 2, those two numbers will add to give you negative 8. So x minus 6, x minus 2. Let's bring that back, and that becomes our new numerator. So up top, 7 times x minus 6 and x minus 2. Again, that was from us simplifying, factoring, and all that stuff. And then at the bottom we have x minus 2, x minus 3, x minus 4. Prime example of why you need to simplify the top. Because now notice, since everything's getting multiplied at the top, everything is getting multiplied at the bottom, you can cancel out the x minus 2's. Therefore, our final answer is 7 times x minus 6 over x minus 3 times x minus 4. Totally simplified. That's our final answer. Alright, 14 and 15, solving some equations. To solve these equations, we're trying to add these two pieces together, so we have to have a common denominator. The way I showed you in class, my preferred way of doing this is to try and get a common denominator for all the fractions. So I'm rewriting these things out. And people forget that 5, sometimes they forget that 5 is 5 over 1. So we still got to get a common denominator there. This one's not too bad though, because we got to have an x in all of them. We got an x there, we got an x there, we got to put an x in this one. So we're good with the x's. Now I've mentioned that. I wrote the 1 there just to remind you it's a fraction, but the 1 is not really that important. We have common denominators. And the shortcut that we can use for solving equations, once you find the common denominator, you can cross them out and solve just the top part. So the top part is 4 equals 2 plus 5x. And solve this equation quickly. We can subtract 2 from both sides, trying to get x by itself. So 4 minus 2 is 2, equals, those 2's cancel, so all we have left over here is 5x. Let's divide both sides by 5. Therefore, we get 2/5 is equal to x. Final answer. Tell you what, we're going to solve both of these problems, and then, we got to check these. Now, I'm going to go ahead and tell you that this one works. We'll have some examples, hopefully, where the answer doesn't work, and we'll come back and check both of these when we're done solving. So let's go and do 15. Now, the shortcut for this one, though, this is a proportion because you have one fraction equal to one fraction. This is one of the only times in mathematics that I want you to cross multiply, if you ever cross multiply. When you have one fraction equal to one fraction, you can cross multiply. We did not have one, we had one fraction here, but we didn't have one fraction on this side, so we could not cross multiply. However, down here we can. So 4 times x plus 1, you got to remember to distribute there. This is equal to the other cross product, so 6 times x minus 8. And let's distribute, so 4 times x and 4 times 1, that's 4x plus 4. Is equal to 6 times x and 6 times negative 8. That gives us 6x minus 48. Solving this equation, I like moving the smaller x to the bigger x, so subtracting 4x from both sides. Therefore, we have 4 equals 6x minus 4x is 2x minus 48. Adding 48 to both sides, we're trying to get x by itself. So we have 52 is equal to 2x, dividing by 2 on both sides, and we get 26 is equal to x. So we just solved those two equations pretty quick. That one's going to work too. We'll have a problem in a minute where it doesn't, but let's check both of these anyway. So 2/5 was our answer for this problem here. We'll use a calculator for this. This one's, you got fractions inside of fractions and all that stuff, and I want you to feel comfortable with using a calculator to help check your work. So I'm going to use the TI-30X. 2/5 was our answer. And what we're going to be doing here is wherever we see, that 2/5, we plug it into here and we plug it into here. So therefore on this side we're going to do 4 divided by 2/5. Let's see what we get. 4 divided by 2/5. We get 10. Alright, hopefully we get 10 on this side when we plug in 2/5. Let's do that real quick. So 2 divided by 2/5. And then we got to add 5 onto it, so be careful there. And notice you get 10. Therefore, our work is correct there. Same thing down here for this one, but hey, these are, I would like it if you could do these in your head too, no doubt about that. So 15, let's check. Now you don't have to show this on your test, but I highly recommend at least checking your work just to make sure you did the problem correctly. So we're going to check number 15. We got to plug 26 into that. So we have 4 over, plug in 26 in right there. 26 minus 8, that gives you 18. On the other side, let's go ahead and plug in 26 over here. So we have 6 over 26. Plug in 26 right there. 26 plus 1 gives you 27. And you might say, hey, these two fractions are not equal. But notice this fraction here we can divide by 2. The top and bottom, we can divide those by 2. So that simplifies to give us 2/9. And over here we can simplify by dividing the top and bottom by 3. 6 divided by 3 gives you 2. 27 divided by 3 gives you 9. Makes me happy because that is the number that makes these two rational expressions equal to each other. 26 is our solution there. The only thing I did over here was a little bit of scratch work to check my work. Alright, so some more rational equations. I'll have a sip of my drink. Alright, so here, how about we go ahead and factor everything that we can. Some of these bottom pieces will factor, and then we'll focus on getting common denominators. So this right here, GCF, we can do 3 times x plus 1. This fraction here, 7x over, maybe I should go ahead and leave some more room as well, because I got to put some new stuff in these. So 7x over GCF, that's going to be 6 times x plus 1. And plus 2x minus 1, this does not factor, so we just got an x plus 1. Now, with the whole with the whole common denominator, when you're trying to find the least common multiple here, I'm going to do a little side note here. Remember that 6 is 2 times 3. And the reason why I'm doing that is because I don't want to make these numbers too big. I'm trying to find the least common multiple to make my work easier, to make my computations faster. Because you might be thinking, well, this has got a 3 in it, so this has got to have a 3 in it. Technically, it does. Now, this one does not have a 3, so we definitely have to put a 3 over here in this one. Now, notice, I'm not looking at the 6 really. I'm thinking of factoring that 6 into 2 times 3. We got a 3 in this denominator, we got a 3 in that denominator, and we have a 3 in that one now. But remember, we had to put that up top. So now we got to do that same thing with the 2. Since there's a 2 in this one, we got to have a 2 in this one. So we're good there. Make sure you put it at the top. That is 2 times negative 5x. And then we got to have a 2 over here in this one as well. Now look at what we really have there. We have 6. 2 times 3 is 6. 2 times 3 is 6. 2 times 3 is 6. And the reason why it is 6 is because 3 goes into 6 and 6 will go into itself. And that's all we really need, because notice all of the denominators already have the x plus 1. So the shortcut when you are solving a rational equation, we are solving an equation here, you can ignore these denominators and solve just the numerator part. So here, when we do this, let's go ahead and do a little bit of multiplication. 2 times negative 5x, that's negative 10x, is equal to 7x. Plus, let's go ahead and do some scratch work here. 2 times 3, we said that was 6. And then let's distribute that 6 to the 2x. 6 times 2x is 12x. Be careful with your signs here. 6 times a negative 1, that's minus 6. Combining like terms on the right hand side, we have 19x minus 6. And now I'm going to move the 19x over here. I know I just mentioned I like moving the smaller to the bigger, but if we were to move the 10x over here by adding it, it does cause confusion amongst students. They're like, well, what do I put down? You know, it would be a 0, but it does cause a lot of confusion. I see it very often. So let's just move the 19x over here by subtracting it. Yes, we have a negative number, but it'll be okay. Negative 29x is equal to negative 6. Divide both sides by negative 29 to get x by itself, and our answer will be x is equal to a positive 6 over a positive 29. That will not simplify any. All right, that one right there, it might have you a little freaked out because of the fact that that answer does not look nice. Well, let's see if it works. And then we'll come back and work out 17. I'm definitely going to use the calculator here because I want to work this out pretty quick. So what did we say our answer was? 6 over 29. Let me squeeze that in right here. Now this should work out. And let's check and make sure. Alright, typing this in, you got to be careful though. That's the only thing about this, because you got all this stuff at the bottom. Watch how I'm going to type this in. Better safe than sorry. If you have a whole bunch of things, a whole bunch of terms to type in, it's a safe bet to put parentheses around your numerator and put parentheses around your denominator. Here's what I mean. So negative 5x, I'm going to do parentheses negative 5, and now we're going to plug in the 6 over 29 for x, so times 6 over 29. There's our numerator inside of parentheses. Divided by, now put your denominator inside of parentheses. Some calculators nowadays, the newer ones, when you do a fraction, it'll give you a fraction bar. This calculator doesn't. So I'm being safe by putting the numerator in parentheses, and we're going to put the denominator in parentheses. So 3x plus 3. I'm typing this in right here. So 3 times 6 over 29, and then plus 3. So over there, all of that, we get negative 2/7. Hopefully we will get negative 2/7 when we type this long thing in. So here's how I'm going to type this in. I'm going to do it all at one time, but we're going to put parentheses around the top, parentheses around the bottom, parentheses around the top, and parentheses around the bottom. Just making sure we plug in 6 over 29 into all these spots where we see an x. And hopefully we will get negative 2/7 on that side. That means that this junk will be equal to all of this junk. Let's do that. So the right hand side, typing this in, you can follow along. 7 times 6 over 29 divided by 6 times 6 over 29 plus 6. All that stuff I just typed in with the parentheses and all that, that was that first piece. Now we can add plus, and now I'm going to type all this in, plugging in 6 over 29 for x. Using parentheses still. So 2 times 6 over 29 minus 1, close it up, divided by 6 over 29 plus 1. Let's see if we get what we want. Negative 2/7. Fantastic. Remember, that's the same exact answer we got when we plugged in 6 over 29 on this side. So that is the correct solution. Don't be scared of weird looking fractions like that. All right, 17. Similar approach, except now we have that subtraction there, so you got to watch your signs on this problem. All right, so rewriting this out, we got to factor that piece over there. And I tell you what, if you can realize that this right here is y plus 4, y minus 4, that'll save you a whole bunch of writing right off the bat. Because we factored this, so really what we're focusing on, now that I've factored it, I've crossed out that piece. So here's how we can find our common denominators right off the bat. We got a negative 1 over y plus 4 minus 7 over y minus 4, and then we have a 8 over y plus 4, y minus 4. Alright, so because we factored that y squared minus 16. That's all I did in that first step there to get that. Now let's compare our denominators. This has a y plus 4 in it. Since that has a y plus 4 in it, everything must have a y plus 4 in it. So we got one there, but we had to put this new at the bottom, so make sure you put it new at the top. Notice I am putting parentheses around here. So we're good with the y plus 4s. They're in all of our fractions. We didn't need to put one over here, so I didn't put one at the top since it was already there. Moving along, we got to have the y minus 4. We got one there, we got one there, we don't have one here. So let's make sure we put it new at the top. Now that we have common denominators, we can ignore them and now focus on solving the top. I'm going to go ahead and distribute here to speed up this process. Make sure you're taking a negative 1 times y. That gives you negative y. Negative 1 times negative 4 is plus 4. Be careful here as well. It's negative 7 times this stuff. You got to watch your signs. So negative 7 times y is negative 7y. And negative 7 times 4, that's a negative 28. And this is equal to nothing but 8 over here on this side. Combining like terms to help solve, minus y and minus 7 is minus 8y. 4 minus 28 is negative 24. This is equal to 8. Adding 24 to both sides, we get negative 8y is equal to 32. And then dividing by negative 8 on both sides to get y by itself, we get y equals negative 4. I'm going to write possible. Possible solution. Here is the thing with this problem. Finally, we have one where it will not work. This is the only answer that we could possibly have. Well, notice if you plugged in minus 4 right there. Back at the very beginning of this video, the first problem we did, we talked about numbers that would make a rational expression undefined. Plugging in negative 4 right there, negative 4 plus 4 gives you 0. That is a big no-no. So because it messes up right there, the whole problem's jacked up. with that solution. I don't care. It would work all right there. -4 would give you -8. But because right there it messes up, it's a no solution. Because there is no other possible answers, therefore what is our answer? No solution. And you might notice too that -4 also messed up in one more spot. -4 squared is a +16. -16 would give you 0 at the bottom as there. Or give you 0 at the bottom right there as well. But it only has to mess up in one spot. So therefore, since that was the only possible answer, it didn't work. We don't have a solution. Oh, look at this one. Number 18. 1 fraction equal to 1 fraction. And lucky us, we already have common denominators. So we can go ahead and ignore them. Look how quick this problem is going to work out. We solve the top stuff. We get 8 equals x. Bam. But remember, this is a possible solution. Again, looking at this, if you plug 8 into the denominator, 8 minus 8 gives you 0. So since it does not work because we get an undefined expression, it actually doesn't work in either one of these, this is another example of a no solution. Be careful there. All right. Moving on to number 19, variation. If x varies inversely as v. Now we've talked about different types of variation, direct, inverse, joint, things like that. X varies inversely. With x varies inversely as v, that equation is going to be x equals k over v. Remember when I said the word inversely, you want to think about dividing by that number. The k is our constant, so k automatically gets written down every time, and it says x varies, so think about it being x equals, automatically go ahead and put your k down, and since you see the word inversely, that means divided by v. Now, the next piece of our information, some people get all this mixed up because they're trying to plug too much in at one time. Notice what I'm going to highlight. X equals 24 when v equals 5. I'm not worried about this right now, this last part. Let's focus our attention on this and let's plug those numbers in. So plug 24 into x. We have 24 equals, we don't know what k is, but we know that v is equal to 5. Solve this rational equation real quick. All you really have to do is cross multiply or just multiply by 5. Because the inverse operation of dividing by 5 is to multiply both sides by 5. So 24 times 5, that's going to give you 120. Therefore, 5 times 24, 120. This is equal to, when you divide by 5 and multiply by 5, they cancel out. There's our k. So again, I focused my attention in yellow to help me out there. The goal is you got to find the k first before you can actually start using or solving other equations. We found our k, so our new equation is now going to be x equals 120 over v. Here's the thing, x and v can vary. They're variables. Now you might say, well, k is a variable too, but k is called a constant, so we will always use 120 at the top. With that in mind, now we can find x when v equals 15. So using this stuff right here in red, we want to find x when v is 15. So all we really need to do here is take 120 divided by 15, and we get x is equal to 8. There's your final answer. But it was a lot of steps and processes to get there, and you can get mixed up in your reading. But we've covered quite a few examples in class, and you've done quite a few in your homework as well. Now, number 20, a variation problem that is real world. I wouldn't call that real world, so you don't have to put a complete sentence. We will need a complete sentence for number 20. The volume of wood in a tree, I'll call that V, varies jointly as the height of the tree and the square of the distance. So volume of wood in a tree, V, varies. The word varies means equals. Automatically go ahead and put down that K right after that. Automatically, right after you put that equals, go ahead and put that K down. You don't see a K up here. K is the constant. It varies jointly. Jointly means you want to join all these other variables. So jointly as the height, so k times h, or you can just write kh, and that's how we did it in class. So we got kh, and then we also have the square of the distance around the tree trunk. Square of the distance. How about d squared, the square of the distance? Notice I did not divide anything in here because I didn't see the word inversely like we did earlier. Jointly means you join everything together. So we got that k that's constant, then we have the height, and then we join that with the square of the distance. So this is our formula. Now let's see how we go about solving for k. If the volume of the wood, let me change colors here. If the volume of the wood is 15.84 cubic feet when the height is 22 feet and the distance around the trunk is 3 feet. Whoa, that stuff in blue is what we got to focus on. All that information is going to let us find k. I guarantee you I'm going to be able to plug in numbers in all these other variables, but we're going to find that constant k. What does it say about volume? Volume is 15.84 cubic feet. So we'll just write 15.84. The height is 22. So k times 22. And then the distance around the tree trunk is 3. But don't forget, you have to take that d, which is 3, and you got to square it. Notice we've plugged in everything. The only number we have left to find is k. So let's solve this equation. 15.84 equals k times, now grab your calculator. Let's do 22 times 3 squared, which is the same thing as 22 times 9. That gives us 198. And now the way it's written there might confuse you a little bit, but it's really 15.84 is equal to 198k. Writing it like that, hopefully you clearly see that you do want to divide both sides by 198. So 15.84 divided by 198, we get 0.08 is equal to k. So now back up here in this formula here, our new formula, since we know what the k, the constant, that's going to always be used, our equation is v equals 0.08 hd squared. Because the thing is, the volume of a tree can change, the height of a tree can change, and the distance around the tree trunk can change, but that constant is always going to be there. So now moving on through the rest of that sentence, what is the volume of wood obtained from a tree that is 29 feet tall having a measurement of 4 feet around the tree trunk? So what we're trying to find there, we're trying to find what is the volume. We don't know. That's what we're trying to find. V equals 0.08. Do we know the height? The height is, the tree is 29 feet tall, so times 29 times the distance around the tree trunk is 4 feet. So make sure we do 4 squared. And now notice you can type all that stuff in right here in your calculator. Do 0.08 times 29 times 4 squared, which is 16. A total of the volume will be equal to 37.12. Now let's make sure we write a complete sentence here. This is a real world problem. So the volume of the tree would be, and this is where the real world comes into play. It's not just 37.12, it's 37.12 cubic feet. Remember, volume is measured in cubic units, so 37.12 cubic feet. All right, 21, find the domain and list the vertical asymptotes. In class, I mentioned this is going into the graphing piece of it. And we didn't do a lot of graphing, but we started talking about asymptotes and zeros and things like that. The vertical asymptotes, what you do is you set that bottom piece equal to 0. And that probably does ring a bell because we've done that before. X squared minus 1 is equal to 0. Solving this equation, there's 2 ways you can do it. I'm going to factor a difference of squares. You could have done the square root method as well, but I'm going to do this. Now we get x equals, setting that factor equal to 0. We've done this back at problem number 1. We get x equals -1, and here we get x equals +1. Now here's where you got to be careful though. The vertical asymptotes, these are your possible vertical asymptotes. You have to make sure though, when you're trying to find vertical asymptotes, you got to make sure that neither one of these factors will cancel out with the top stuff. So watch what I'm going to do. I'm going to rewrite f of x and I'm going to factor everything. 8 times 6 is 48 and 8 plus 6 is 14, so we have x plus 6, x plus 8 over, and we already factored that bottom piece. We said x plus 1, x minus 1. Now notice this thing will not simplify. Nothing cancels out. Therefore, both of these are vertical asymptotes. Had something canceled out, it would have been something called a hole. We've talked about it in class, but we don't have any holes here. Since neither one of these canceled out, they're both vertical asymptotes. So we have two answers. We got x equals -1, and we have x equals +1. Now using these values, now these numbers actually mess up the problem. You can't plug -1 into this thing because you get 0 in the bottom. You can't plug +1 into this thing because you get 0 at the bottom. They're called vertical asymptotes. We've seen them on graphs. I've given you some previews, and we're going to look at that in a few minutes as well. So there's our VA. Now, x can be any other number in the whole wide world except for -1 and +1. So therefore, our domain, using some interval notation, we can do any number in the whole wide world except for -1 and +1. That means we can go from negative infinity all the way up to -1. I'm putting a parentheses because I don't want to include -1. Or we can go from -1 to +1. There are some numbers between -1 and +1. Zeros between there. We have some decimals and fractions in between there. But notice I did not include, I didn't put brackets around those because we don't want it to be equal to -1 or +1. Or we can go from +1 on forever and ever and ever and ever. This weird way, it is important, interval notation, is another way of saying x can be any number except for -1 and +1. Any other number from negative infinity all the way up to -1, such as -1 million, -2 million, -5. Anything in there all the way up to -1. Then we could have any number between -1 and 1. You can plug in any number between here and it'll work out. Or you can plug in any number that's bigger than 1. So 1 on to infinity, but we don't want to include 1 because it messes that problem up. You get 0 at the bottom. Alright, so grabbing a graphing calculator real quick. When you take a college algebra class, that's when you'll start focusing on the pencil and paper techniques real deep. But for sake of time here, those are our two answers. I do at least want to show you the vertical asymptotes. So going to y equals, I showed you this in class too. I'm using my parentheses on this calculator as well. X squared plus, well, I'll tell you what, this is what I was talking about when if you had the upgraded calculators, and they actually have some calculators that are much nicer than this too, color screens and all that. But there's a function or a thing on this calculator that lets me, I think it does. No, maybe it doesn't, but x squared, screw it, I'm going to use parentheses. X squared plus 14x plus 48. As much as I like technology, I'm still not 100% efficient with these calculators. So there's our top part in parentheses, our bottom part, x squared minus 1. And I'm just going to show you the graph. We had some vertical asymptotes, and that means that graph is going to start to freak out around those points. Now, something that I don't like about the way this graph looks right now. Vertical asymptotes. We said our vertical asymptotes were at -1 and +1. This is what I'm talking about right here. This is when x is equal to -1. And this right here is when x is equal to +1. Those are supposed to be vertical lines. Now notice over here, this graph does start to freak out as it gets close to that red line. It starts to shoot up real quick. Now, I don't see any part of the graph between -1 and +1, but there's supposed to be some stuff in there. And what's happening over here, as this curve over here is getting close to +1, it's starting to freak out as well. If I were to change the window, whoops, if I were to change the window, we could actually see more of this graph. I tell you what, Let me do this. Okay. Watch this. I do want to show you that the graph does have some values between -1 and +1. I want you to see a little bit of this graph. So I'm going to change my window real quick. Let's do our Y min. You might say, well, how do I know to do this? That'll come when you take college algebra, but I at least want to show it to you. Just changing that right there, it's going to change the way this graph looks quite a bit. Notice what I got right down there. That's what I wanted you to see. Okay, this right here, if we drew a vertical line through x equals -1, the graph starts to freak out and hug it right up here. Notice that here you have that little curve. That curve is starting to freak out and it's hugging this dotted line, this imaginary dotted line. That graph is hugging it down there. Now also where x is equal to +1, I mentioned earlier where this graph starts to freak out and it's hugging this imaginary dotted line that I'm drawing right here. And then down here at the bottom, notice that it's starting to freak out. You can see a little bit of it bulge out right there, but it's starting to freak out as it gets close to that imaginary dotted line. So those are our vertical asymptotes. And I mentioned the domain too. X can be anything except for those values of -1 and +1. All right, number 22. We're dealing with a distance, rate, and time problem. The current in a stream moves at a rate of 4 miles per hour. That's going to be the rate of the stream. Either it's going to be pushing us at 4 miles per hour or it's going to be pushing against us at 4 miles per hour, depending on whether we're going upstream or downstream. If a boat travels 82 miles downstream in the same time that it travels 41 miles upstream, what is the speed of the boat in still water? So we got some important pieces of information. The 82 is going to be important. The 41 is going to be important. Our two scenarios here are we're going upstream and we're going downstream. For distance problems, we have a rate times some amount of time, and that's going to be equals to some distance. Rate times time equals distance. All right, let's start filling in some information. We know that the distance that the boat travels downstream, 82, see that right there? 82 miles downstream. So downstream, the distance downstream is going to be 82. 41 miles upstream is going to be the distance that we travel upstream, 41. Now the reason why we're traveling a longer distance downstream is because when you go downstream, you have a current pushing you. You have your speed plus the speed at which the current is pushing you. Whereas if you go upstream, you have the speed that you're traveling, but you're going to actually take away some of that speed because the stream is pushing against you. Here's what I mean. We're trying to find the boat speed in still water. So that's part of the rate. If we're going upstream, the water's pushing against us. So we're going to subtract 4 because the rate of the water is 4 miles per hour. So we got the boat speed, subtract 4 from that. That's going to be our rate or our speed going upstream. Whereas if we're going downstream, we have our boat speed plus the water is pushing us, so we're going 4 miles per hour faster. Now some other information, we've got to fill in these t's. Notice it does talk about the same amount of time. So if this is t, we travel for t hours, we're going to travel for t hours here. We're traveling the same amount of time upstream that we travel downstream. Now, using our formula, rate times time equals distance, our rate is b minus 4, times our time, which is t, rate times time, and it's equal to our distance. There's one of our equations. Our other equation, very similar. Our rate is b plus 4, times our time, which is t, and this is equal to 82. That's our distance there. Now, since we're trying to find the speed of the boat in still water, that means we got to solve for b. But we got two different types of variables, and I mentioned this in class. If we were to divide by b minus 4 on both sides, notice the b minus 4's cancel out over here, so that equation right there becomes t equals 41 over b minus 4. We just got t by itself. There's a reason why I'm getting t by itself. Let's do the same thing for this one. B plus 4. Let's divide by b plus 4 on both sides. The b plus 4's cancel, so we have t equals this stuff right here. Now the reason why I'm doing this is because of that question. We're trying to find the speed of the boat. We're trying to find b. Well, notice that we have t equals to this stuff, and this stuff that t is equal to has the b in it. Well, t is also equal to this stuff which has a b in it. So if t equals this and t equals this, then this and this must be equal to each other. If t equals this junk, t equals this junk, then these two pieces have to be equal to each other. So let's set them equal to each other. 41 over b minus 4 is equal to 82 over b plus 4. Now from here, all we really have is a proportion, to be quite honest with you. You can cross multiply 41 times b plus 4. And the reason why we can cross multiply is because we have one fraction equal to one fraction. So cross multiply here, 82 times b minus 4. And now it's nothing but a bunch of distributive properties and some equation solving. So 41 times b is 41b. And then 41 times 4, that's plus 164. This is equal to 82 times b is 82b. And then 82 times negative 4, 82 times a negative 4, we get negative 328. I'm going to move the 41b over by subtracting, trying to get b by itself. So therefore we have 164 is equal to 41b minus 328. And now let's add the 328 to both sides. Still trying to get b by itself. So 328 and 164, that gives you 492 is equal to 41b. And again, I'm not showing all my canceling steps, but we're solving an equation here. So divide both sides by 41 to get b by itself. And if you take 492 divided by 41, we get 12 is equal to b. The whole point was to find b, the speed of the boat in still water. So I got t by itself in both of these equations, which gave us equations that have b's in it. And that's the whole point of this, because now we could solve for b. Therefore, our answer is the speed of the boat in still water is 12 miles per hour. That's the answer. We're done with the problem, but you know me, I'm going to explain it a little bit more. That's our answer. If you understand it, you're good. Go on to the next problem, but I do want to talk about it a little bit more in depth. If the speed of the boat, we got b equals 12 here. So if b equals 12, actually we're going 8 miles per hour upstream, because if you take 12 minus 4, you get 8. Well, let's see here. 8, that's our rate, times t, which is our time. So rate times time is equal to our distance of 41. Alright, so we got that one. Where are we going to put that at? We'll put it right here. Our other one, rate times time equals distance. So what is our rate? If the boat speed was 12, but now we got the current pushing us. 12 plus 4, we actually go 16 miles per hour downstream. So that equation is going to be 16t is equal to 82. Rate times time is equal to distance. And the reason why I'm showing you this is because I want you to realize that we're going to travel. Notice the problem said we travel for the same time upstream and downstream. Well, if we solve both of these equations for t, if we divide by 8 here, we get t equals, what's 41 divided by 8? 5.125. Let's divide by 16 over here for this one. If we take 82 divided by 16, oh, look at that. You get t is equal to 5.125. What I'm trying to get you to realize is that you've done the problem right. We're trying to check our work. Since we're getting the same t value here, that means we did the problem correctly, because it says in the problem that the boat traveled the same amount of time that it did upstream as it did downstream. And everything works out perfect. But again, the real answer here is the speed of the boat in still water is 12 miles per hour. Number 23, Martha can rake the leaves in her yard in 2 hours. The shortcut for this one, if Martha can rake the job in 2 hours, where's my pen? The shortcut I told you to take is she can do half, 1/2 x. You take that number and you reciprocate it. The reciprocal of 2 is a half. Throw an x beside it. Her younger brother can do the job in 5 hours, so he's going to be 1/5 x. Now the way I want you to think about this, all the stuff that I'm writing down, we always add them and we always set it equal to 1. So what Martha's going to be doing, she can do half the job, plus her brother can do 1/5 of a job, but it's actually half of the job in an hour, plus 1/5 of the job in an hour is going to be equal to 1. Now that 1 represents 1 full job. That 1 full job is actually them raking the yard together. So we're trying to figure out how long will it take them if they work together. If we solve for x, we will get the amount of time that it takes them to complete 1 full job, in this case, raking the yard together. So I'm going to rewrite this as x over 2 plus x over 5. All I did there was just take x times 1 is x times 1 is x, and this is equal to 1. Alright, so our common denominator is actually going to be 10. Because if you multiply by 5 here at the top and bottom, and multiply by 2 here at the top and bottom, notice you get 10. You get 10, so we got to have 10 over here at the bottom of this one. So let's multiply the top by 10. So what we're looking at is 5x over 10 plus 2x over 10 is equal to 10 over 10. That's the exact same expression. 10 over 10 is still 1 full job. 2/10 is still 1/5 of the job. 5/10 is still half of the job. And now solving this rational equation, the shortcut I told you, once you get common denominators when solving a rational equation, you can cross them out. So we have 5x plus 2x is equal to 10. And then from here, 5x plus 2x, that's 7x is equal to 10. Divide both sides by 7. So we get x is equal to 10/7. Now this is actually 10/7 hours. I talked about time a lot in class too. I'd rather see that as a mixed number. How many times does 7 go into 10? 1 time, with 3 left over. So that sounds better to me. 1 3/7 hours. So together, they can rake the yard in 1 3/7 hours. 10/7 hours is not wrong, but it rolls off the tongue better, and it makes more sense if we say 1 3/7 hours. That does not mean an hour and 37 minutes. That does not mean an hour and 30 minutes or an hour and 7 minutes. Just leave it like that. 1 3/7 hours is fine. Now, if you start thinking about that, how much time is that really? 3 is not quite half of 7, so they can do the job in a little less than 1.5 hours. A little less than that. But that's your solution there. They can rake the yard together. If they work together, they can do it in 1 3/7 hours. Number 24, similar triangles. Since the problem says the triangles are similar, we can use some rational equations, but in all honesty, we're just going to be doing some ratios and proportions. So if the upper triangle, or in the upper triangle, the shortest side is 22. So we got a 22 right there. That looks like the shortest side in the upper one. The middle side has a length of 33. That looks like the middle one. That looks the longest one to me. In the lower triangle, the shortest side is 18, so that would go there. The middle side is 27, and the longest side of that bottom triangle is 36. I guarantee you, without having to read anything else, we're going to be trying to find that side right there. Find the length x, oh, look at that, I even wrote x, of the longest side of the upper triangle. So we're trying to find this. Well, first of all, let's make sure these triangles are similar. We should be able to take this short side, divide by that short side, 22 over 18. Let's go ahead and get a decimal out of that, just for right now. 22 divided by 18. You get 1.2 repeated. 22 divided by 18, yeah, I don't know if I quite said 22 over 18, but anyway, 22 divided by 18 is 1.2 repeated. We should get the same exact decimal if we take the middle side here divided by that middle side. 33 over 27. 33 divided by 27. Oh yeah, 1.2 repeated. That's what makes something similar or proportional. These ratios have to be equal. Even though we have two different numbers, we get the same number when we divide them that we get down here. Now you can pick either one of these ratios. You can either do 22 over 18 or 33 over 27. I'm going to do 22 over 18. And set this equal to, since I use the shortest side of the upper triangle, I need to make sure I use the longer side of the upper triangle and put it over 36. So really what we have here is we have upper over the lower is equal to the upper over the lower, and I'm just matching up my numbers with the triangles. Let's cross multiply to solve. 22 times 36, that gives us 792. Oh my goodness. All right, 792 is equal to 18x because the other cross product is 18x. So therefore we have to divide both sides by 18 to get x by itself. Therefore x is equal to 44. So complete sentence, this is kind of a real world problem. The longest side of the upper triangle is 44. And since they didn't give us inches, yards, or anything like that, all we can say is 44. But again, if you were to take 22 divided by 18, we said it was that. 33 divided by 27, we said it was that. If you take 44, which we just found, and divide it by 36, I'm going to do that real quick, we should get 1.2 repeated. And we do. And last but not least, number 25, a quality control inspector examined 200 calculators and found 8 of them to be defective. 200 calculators. Out of those 200 calculators, 8 of them were defective. Now you don't have to include these letters. I'm going to actually erase them in a minute. As long as you remember, you want calculators at the top and you want the number of defective at the bottom. And I just use those two numbers right there. At that rate, how many defective calculators will there be? That's the question we're trying to find. We're trying to find how many defective. So notice I put defective at the bottom here. You got to put defective at the bottom here. In a batch of 15,800 calculators. Now, don't let these variables confuse you. I'm going to erase them. I just wanted to remind myself I put calculators at the top over the number of defectives at the bottom. So this is really what we're looking at. 200 over 8 is equal to 15,800 over x. This is another proportion. You got a fraction equal to a fraction, cross multiply to solve it. 200x is equal to, and multiply that, 15,800 times 8, 126,400. Divide both sides by 200 to get x by itself. So we have x is equal to 632. Therefore, we can say in a batch of 15,800 calculators, there will be, now I'm going to use the word approximately, 632 defective calculators. Now the reason why it's approximate is because you're not going to have exactly 632. It's probably not going to happen. But at the rate the inspector saw this, out of 200, 8 of them were messed up. He can expect to have around 632 of them being defective out of a big old batch of 15,800 calculators. But if you left off the word approximately, I'm not going to penalize you for it. But it's probably not going to be exactly 632. But I think that's it. Let's see. 25 problems if I'm not mistaken. Yeah. So there it is, the entire DMA 70 review. And that is it for this long video. Hope it helped.